Hello viewers, I am Dr. Mala Das Sharma and you are watching my channel Chemphilic. So let's start the 18th episode of Teaching Chemistry through Riddle. Do watch the video till the end so that you can enjoy the riddle completely. So let's start the riddle number 18. Mr. Y is bright, colorful but poisonous. He may kill you also. He is very much afraid of heat as he loses his color upon heating. He looks brighter when associated with ammonia solution. He, along with his friend Ferrocyanide, can prepare a product which has an identical property of cell membrane. So, this is riddle number 18. Now, let's see the question. The primary question is, who is Mr. Y? The answer is hydrated copper sulfate. That is copper sulfate, 5 molecules of water of crystallization. Now question number 2. Why does he lose his color upon heating? The answer is, see, when you are heating copper sulfate, that is hydrated copper sulfate, then it loses its water of crystallization and becomes dehydrated. The dehydrated copper sulfate is white in color. So upon heating, it loses the water of crystallization and becomes dehydrated copper sulfate, which is white. So copper sulfate molecule is blue and it has 5 molecules of water of crystallization. Upon heating, it loses the water of crystallization and dehydrated product is white. Now question number 3. Why he looks brighter when associated with ammonia? Discuss in detail. The answer is, look at here. This is copper sulfate solution, blue in color. If you add small amount of ammonia solution or ammonium hydroxide, then copper hydroxide is formed. This one, it's like precipitate of copper hydroxide you will find, and in that case, this ammonium hydroxide is acting as base. But when you are adding excess ammonium hydroxide, then this ammonia acts as ligand and it forms the copper tetramine complex, which is deep blue in color. So when cupric salt is treated with excess ammonia solution, deep blue colored copper tetramine complex is formed. Now, structure of copper tetramine complex. In copper tetramine complex, copper is attached with 4 ligand, that is 4 ammonia ligand. Let's explain the structure. Electronic configuration of copper is 3D9 4s2. This is the electronic configuration, but one of the 4s electron gets unpaired and comes to this d orbital or 3d orbital, so that this 3d orbital becomes fulfilled. We know that fulfilled orbitals are more stable. Now, when cupric ion is formed, then this 1 electron from this 4s and 1 electron from 3d orbital is removed. And then what happened? The remaining 1 electron is promoted to this higher energy 4p orbital. Now one 3d orbital, 4s orbital and 2 4p orbitals are vacant, and this 3d orbital, 4s orbital and 4p orbitals, they undergo hybridization, that is dsp2 hybridization, and form 4 dsp2 hybrid orbitals. These hybrid orbitals accept the pair of electrons from the ligand. That means it accepts the 4 pairs of electrons from 4 ammonia ligand. So the structure is square planar and this molecule is paramagnetic because this 4p orbital contains one single electron or unpaired electron. Now, this X-ray analysis of cupric complex proves that the ligands are coplanar. All four ligands are in the same plane. Therefore, it is confirmed that hybridization is dsp2. It is not sp3. In that case, it cannot be planar. So, copper tetramine complex is square planar. Confirmed. Now, question number 4. What is question number 4? What is the product with ferrocyanide? Discuss the property of the product that is identical to cell membrane. Now, what is the product? Answer is, the product is the brown colored or chocolate colored precipitate of cuproferrocyanide. It has the property of allowing only the solvent through it. That means only the solvent can pass through it but not the solute, just like semipermeable membrane. Now coming to semipermeable membrane. Semipermeable membrane are generally animal membrane. If you take egg and then if you remove the hard outer shell carefully, then you will find a thin membrane, that is semipermeable membrane. Semipermeable membrane, it allows the free passage of only solvent molecules through it but not the solute molecules. Okay? It has this property. Now, there are two phenomena are shown here. One is osmosis. In case of osmosis, when two solution, one is concentrated solution and say one is little dilute solution. If they are separated by semipermeable membrane, then solvent from this dilute solution pass through this semipermeable membrane and comes to this concentrated solution side till the both side solution becomes equally concentrated. Means concentration of both the side solutions are same. Similarly, if one solution and one solvent, that means one side solution, one side solvent, they are separated by semipermeable membrane, then due to osmosis, this solvent pass through the semipermeable membrane and comes to this solution side and make it dilute. And this is another phenomenon, diffusion. In case of diffusion, not the solvent, solute molecules from high concentration goes to the solution of low concentration. Here solute moves from high concentration to low concentration. So, in osmosis, pure solvent molecules pass through a semipermeable membrane from a solution of low concentration to a solution of higher concentration, or solvent passes through semipermeable membrane to solution when solute and solvents are separated by semipermeable membrane. Now, copper ferrocyanide complex. Copper ferrocyanide complex, which has the property identical to semipermeable membrane, are frequently used in the laboratory. So, copper ferrocyanide complex, which can be prepared in the laboratory, it has the property of semipermeable membrane. That means it allows only the solvent to pass through it, and it is very strong and it can withstand very high pressure. So, this is copper ferrocyanide or cuproferrocyanide complex. Here copper sulfate, from copper sulfate, copper ion and sulfate ion produced, and potassium ferrocyanide, potassium ion and ferrocyanide produced. Then cupric ion and ferrocyanide combine to form this complex, cuproferrocyanide or copper ferrocyanide complex, which is chocolate colored or brown color. Now, laboratory preparation of copper ferrocyanide semipermeable membrane. Now, here what you have to do, this is a porous spot, and this porous spot is filled with copper sulfate solution, dilute copper sulfate solution, and this porous spot is placed in a beaker, and the beaker contains the dilute solution of potassium ferrocyanide. Okay. And so, this clean porous pot filled with copper sulfate, and the pot is placed in a beaker having the dilute potassium ferrocyanide solution. A copper electrode which acts as anode is dipped in the solution of copper sulfate, and a platinum electrode which acts as cathode is dipped in the solution of potassium ferrocyanide, that means in the beaker. So copper electrode acting as anode is placed in the porous pot, and the platinum electrode acting as cathode is placed in the beaker. Now what happened during electrolysis? When you pass this electricity, what will happen? This copper ion, which is positively charged, it will go towards this cathode. Okay, and in the beaker, here you have potassium ion and ferrocyanide ion. Ferrocyanide ion is negatively charged, so it moves towards this anode. So copper ion is moving towards this direction, and the ferrocyanide ion is moving in the opposite direction, and both the ion meets at the pores of this porous pot, and copper and ferrocyanide, when they meet, they form the cuproferrocyanide complex, gelatinous precipitate, which is settled down at this porous pot. So, on passing electric current, copper and ferrocyanide ion move in the opposite direction and meet in the pores of the pot to form the gelatinous precipitate of copper ferrocyanide layer. Then you have to take out this porous pot, you have to wash it thoroughly, and that can be used as semi-permeable membrane. So after precipitation of the membrane, the pot is removed and washed with distilled water. So this was the riddle number 18. Hope you have enjoyed.